Welcome to part 2 in the Mongoose BOD integration tutorial. In the last video, we looked at a custom Mongoose app that provided a vendor portal for purchase order data synchronized with Infor ERP LN via ION, and we showed how to configure Mongoose to be ready for communication with ION. Now we're going to look at how BODs come into Mongoose. The first thing we're going to look at is the replication document inbox form. When ION sends a BOD to a Mongoose application, it will become visible here before the Mongoose services continue processing it. If we filter for the BOD we generated, here's our purchase order BOD that was transmitted from LN. The document ID is 374, and the logical ID shows that it came from LN, and the BOD received was a sync purchase order. Let's take a step back. A BOD is a business object document, and in the real world, this would be a physical document exchanged between two systems. A BOD is a representation of that physical document in XML. The layout of the XML comes from the Open Applications Group Integration Specification, or OAGIS for short. A BOD consists of two pieces, a noun and a verb. The noun identifies the business-specific data that is being exchanged. The list of nouns is based on the OAGIS standard and, for example, could be a sales order, shipment, and in our case, the noun is purchase order. The verb identifies the action that's going to be performed with the noun data. Some examples of verbs are cancel, process, add, and in our example is sync. The verbs again are based on the OAGIS standard. In the case of sync, when a system that is the system of record for the noun makes a change to the data, it needs to transmit a sync BOD, so any other systems that are not the system of record for the noun can respond and update their local data. The noun and verb are used to cross-reference the metadata that tells us how to process the BOD. The remainder of the document is XML Xpath information that represents the elements of the BOD. In this case, whenever our Mongoose app receives a purchase order sync, the app will replace any information that it has on the purchase order with the new information. For example, if Mongoose needs to change information on the system of record, it must send out a purchase order BOD with the verb process. In our case, since Mongoose is not the system of record for purchase orders, we receive sync BODs and send out process BODs for the noun purchase order. This XML data at the bottom is what we are looking to read in and translate into data that we can put into the IDOs and tables within Mongoose. We'll look at that in a second, but first let's open the SQL tables form and take a look at the two tables that we're translating this XML data into. The first table, named PO_header, contains header information, and if we look at the columns on this table, we have columns for address and terms information, purchase order date, purchase order number, and a promised delivery date. This delivery date is the one that we're going to change in Mongoose and communicate back to LN. If we select the second table, named PO_lines, we see that we have columns containing purchase order line information, description information for the item, and quantity information. Now that we've looked at the SQL tables we're using, let's open the IDOs form and look at the IDOs that we've built on top of these tables. Here we see an IDO named purchase order header and another named purchase order lines. These were both built using the standard process of building an IDO from a table. To see more information on this process, see the training videos available on the Mongoose portal or the Mongoose online help. If we look at purchase order header properties, we've created a subcollection called INNO PO lines. We've created the parent-child relationship between the PO header and PO lines information and created that as another property. If we look back at our Mongoose app, we can see where this property gets used. Our purchase order header information exists in a collection called INNO PO header. The grid at the bottom of the form displays the information from the subcollection. We have columns which are bound to IDO properties of the subcollection. The PO_num column is bound to the IDO property named PO_num, which is in the INNO PO lines subcollection. The PO_item column is bound to the IDO property named PO_item, which is also in the INNO PO lines subcollection. So there's the relationship established within our application that we've built on top of these two IDOs and our table. Now let's look at the XML that contains all of the information that we need to read in to those two tables. We need to cross-reference this XML information from the inbox to a replication document that can process it. Go back to Modules, System, Replication, and open the Replication Documents form. We want to look at a replication document called Purchase Order. Generally, it's a good idea to name the replication document with the BOD noun. We're going to specify the INNO PO header IDO as the primary source for this document. But remember that PO lines is already included as a subcollection, so that data will also be brought in. At the top of the form, we have a button labeled Inbound Cross-References. An inbound cross-reference tells Mongoose what to point to when it receives a document. This cross-references any incoming BOD with the noun purchase order to the replication document named purchase order. So when that inbound value comes in, it's then cross-referencing this purchase order with this document, but only if the BOD verb is sync. You could have multiple inbound cross-references based on different BOD verbs, but generally we only send, process, and sync BODs. So if we were to receive a BOD to process a purchase order record, we would also need an inbound cross-reference using the verb process. But because we aren't the system of record for this BOD, we have a sync BOD instead of a process BOD. Looking back now at the replication document inbox, let's talk about consuming a BOD. The first thing we have to do when we're creating a document is to create the header information. The header information highlighted here identifies where the BOD came from and what type of BOD we're receiving. We have to denote that information first. On the replication documents form, there is a button labeled Add BOD Header Elements. This adds all of those header elements automatically. This refers to the functions that are seen here, showing the from logical ID. When we go to send a BOD, this information becomes very important. When receiving a BOD, this information isn't as important, except that it needs to be here in order for the mapping to work, to decode the information as it comes in. With a header in place, we can look at all of our elements by clicking on the Elements button. Now let's explain Xpath a little bit. Xpath is a query language for selecting nodes from an XML document. In order to get the logical ID from the incoming BOD, we need to know the Xpath to the logical ID. Let's take a look at this sync purchase order, application area, /sender, /logical ID. Let's walk through this in the XML. We have sync purchase order, application area, sender, logical ID. The first row of the BOD tag name column shows BOD verb, BOD noun. These two functions are available in the replication and allow us to denote what the BOD verb and BOD noun are. Mongoose figures out automatically what the BOD verb and BOD noun are, and remember that here our BOD verb is sync and our BOD noun is purchase order, as you can see from the XML. We then need to take the entire XML document and map the Xpaths with their associated tags and values to values on our IDO. The next part of the tree is the data area. We're going to go down a few levels here and look at purchase order header, document ID, ID. Looking at the form, we have that information and we're going to assign a value type. We can have literal values, which are usually for outgoing BODs. So when we're sending out a BOD, we can have a value that just says send this hard-coded value. This is a mapping tool that maps from an XPath within the XML to a property value contained inside of this replication document. When we're receiving or sending, we can have property tag information. Property tags are properties contained on the IDO. On our purchase order header IDO that we denoted on the top level replication document, we have a purchase order number, PO num, which is located on our IDO, and subsequently also on our table. Once we've established that mapping, we then go through and establish all of the properties on the XML document. Eventually we get down to subcollection information. We define purchase order header information, but then we get down to line item information. Tracing through our tree again, we get to purchase order header, purchase order line, then line number. Of course, you can have multiple lines on a purchase order, and likewise you can have multiple lines attached to a header or attached as a subcollection to our header information in our IDO. If we look again at the replication document, when we want to denote item ID, we want to again take this path through the XML. So we have purchase order line, item, item ID, ID, and this is the information that relates to the property. This is the item that we would find on our purchase order. Taking a look at our replication document for the mapping, we have again our Xpath information, property tag, and PO line information. And here we have PO item, and it's prefixed with the subcollection ID from the purchase order header IDO. We were looking earlier at the IDO, and we assigned that property within the purchase order header information for INNO PO lines. We're going to use that prefix here, which is .PO item. Again, because of the way that the XML is listed, we would have multiple purchase order lines contained within a purchase order. So for example, under the purchase order line, we have line number 10, then we might have another purchase order line, which would be line number 11, and so on. That is the way that we map all of these items. We'll also see information contained inside of the tag information. Let's look at an example of that in our incoming XML. On purchase order line, and take a look at quantity, which has a value of 100. Between those quantity tags, there is also another value in there, which is called an attribute. The quantity of 100 is coming in, but we're also recording a unit of measure in there. This is referred to as unit code, and this one specifically is each. We want to capture this attribute information that's contained within our quantity. You can have multiple attributes assigned here. You'll notice another attribute we have on this document is currency ID, and it can also denote site information and other types of information that would be exchanged. Let's look back at our document and take a look at the Xpath for purchase order line and look at the quantity tag. We have an attributes button. Attributes are an XML construct, which are name-value pairs associated with an element in the XML document. We see we have an attribute called unit code, and that relates to the attribute as listed within the XML called unit code. And we have a property tag on our PO line subcollection called unit of measure. When we receive this document, we're not only just going to have the quantity of 100 placed into the table, but we're also going to place in a unit of measure of each into the PO line's unit of measure field. We're going to draw the line there for video 2. To recap, we looked at what a BOD was made of, and then we looked at the SQL tables that we were reading the XML data into. Then we looked at IDOs that were built on these two tables, and inbound cross-references in our example. Finally, we looked at mapping BOD elements and attributes to collection properties. In the next video, we're going to talk about the ION configuration, executing a BOD, and how it's processed by Mongoose.